Welcome students. In the last lecture, that is limit of the indeterminate form, that was part 1, we covered the basic formulas of differentiation plus some of the standard limits, and we did also some of the numericals based on limit of indeterminate forms based on type 1. Type 1, basically there are 4 types of limit which we will be reading, that is 0 by 0 or infinity by infinity, that is type 1. Second type would be 0 into infinity. Third type would be infinity minus infinity, and fourth type would be like 1 to the power infinity or infinity to the power infinity forms like this. Okay, so let's solve some of the numericals from the previous session just to make you more comfortable for this topic. Evaluate the following limit x tends to 1, x to the power x minus x divided by x minus 1 minus log of x. Okay, so what was for first step? Let put the values of x as 1 because x tends to 1. So can we say 1 to the power 1 minus 1 divided by 1 minus 1 minus log of 1. Okay, so log of 1 is 0. So can we say the numerator is coming 0 and denominator is also 0. So when numerator and denominator both are 0, what we used to do? We used to apply the L'Hospital rule. L'Hospital, and what does the L'Hospital rule says? We differentiate the numerator and denominator, okay, simultaneously. So limit x tends to 1. So again, here is the major task, that how do we differentiate x to the power x? So let's do it in a different way. Let us consider y is equals to x to the power x. Okay, so what can we do? We can take the log on both sides. So taking log can put your result like this: log y is equals to x log of x. Again, this is a different function, this is a different function. Okay, so now differentiate it with respect to x. So differentiate with respect to x. So can we say log y is given by 1 upon y and dy upon dx, and this is, how do we differentiate this? First consider this as constant and differentiate this. Thereafter consider this as constant and differentiate this. Okay, so let us write this x d by dx of log x plus log x and d by dx of x. Okay, what is the value of this one? This is 1, and differentiation of log x is 1 upon x. So can we say x into 1 by x plus log x, and this is 1 upon y dy upon dx. So can we say dy by dx is nothing but y into 1 plus log x. And what is y here? What is y? Y is nothing but x to the power x, so 1 plus log x. So differentiation of x to the power x is given as x to the power x into 1 plus log x. So write it here: x to the power x 1 plus log of x, and differentiation of x is 1 divided by differentiation of x is 1, differentiation of 1 is 0, log x differentiation is 1 upon x. Clear? Again, let put the values at 1. So 1 to the power 1, 1 plus log of 1 minus 1 divided by 1 minus 1 by 1. Again it is coming at 0 by 0 form. So when again it's 0 by 0 form, so let's again apply L'Hospital rule. Apply L'Hospital rule. Okay, so again differentiate it. So again there are two functions. What is first function? X to the power x is first function, 1 to the power log x is first function. So let's say x to the power x and d by dx of 1 plus log x, okay, plus 1 plus log x consider करें. Let's consider 1 plus log x constant and differentiation of x to the power x, and 1 का differentiation is constant. Okay, in the denominator 1 का differentiation 0, minus 1 upon x का differentiation minus 1 upon x square. Okay, so let's further differentiate it. So x to the power x, what is the differentiation of 1 plus log x? So 1 differentiation of 1 is 0 and log x differentiation is 1 upon x. Clear? And plus 1 plus log x, and we have already calculated the differentiation of x to the power x is x to the power x into 1 plus log x. So let's write it there as to the 1 plus log x, and in the denominator it is 1 upon x square. So let's simplify it once more, that is limit x tends to 1, can we say x to the power x minus 1 plus x to the power x into 1 plus log x whole square divided by 1 plus x square. Now put the values of 1. So can we say 1 to the power 1 minus 1, 1 into 1, 1 plus log 1 whole square divided by 1 by 1. So this is 1 to the power 0, can we say 1 plus 1, 1 plus 0 ka whole square, can we say 1, and the final answer is 1 plus 1, 2. So 2 is your final answer. Okay. Now let's focus on one more numerical which is commonly asked in the academic examinations of your semester examination. Basically, what is the given question? Find the values of a and b such that limit x tends to 0 x into a plus b cos x minus c sin x divided by x to the power 5 is equal to 1. Okay. So how do we solve this one, this part? So let's first simplify it. Limit x tends to 0, can we say a plus b cos x, okay, minus yeah, let's first put the values over here just to check it. So if we are putting the values at 0, 0 into a plus b cos 0 minus c sin 0 divided by 0 to the power 5. So can we say this is 0, this is 0, this is taking 0 by 0 form. Okay, so this is taking 0 by 0 form. So let's differentiate, and let's differentiate it. It's 0 by 0 form. So differentiating the numerator, can we say the result can be also written like this? How do we differentiate this? Again, product rule, keep it at constant, differentiate this, again keep constant this and differentiate x. Okay, so can we say a plus b cos x, we are keeping it as constant, d by dx of x plus x into d by dx of a plus b cos x, and c sin x differentiation cos x divided by 4x to the power 5x to the power 4. Okay, so again simplify this, can we say differentiation is 1 and this differentiation is minus of sin x. Okay, and b is also multiplied there. So what would be our final result? Limit x tends to 0, can we say a plus b cos x minus bx sin x minus c cos x divided by 5x to the power 4. Let us say this is equation number 1. Okay, so for x is equal to 0, let us say when we are putting the values as x is equal to 0, okay, so x, let us say if we'll put x is equals to 0, okay, then the numerator will be finite limit if and only if the numerator also becomes 0 for x, because numerator and denominator both will be 0, then it will be only finite limit. So how the numerator will be 0? We'll put the x is equal to 0 in the numerator case. So a plus b cos of 0 minus b into 0 into sin 0 minus c into cos 0 is equal to 0. So let's make the numerator as 0. So what is the condition? This is 0, can we say, and this is 1. So can we say the condition is a plus b minus c is equal to 0. So this is the condition number 2. But what we have assumed that numerator is 0. That is the reason only, because numerator and denominator will, if both will be 0, then only it's the possible limit can be find out. Okay. So how, assuming that it forms the 0 by 0 form, assuming that it forms the 0 by 0 form. Okay, so how do we calculate? If it's making the 0 by 0 form, then we'll have to apply the L'Hospital rule and differentiate it one more time. So apply here, apply L'Hospital and differentiate it one more time. So differentiation of a is 0, b cos x differentiation is minus sin x, minus b, what is the differentiation of x sin x? Again x cos x plus sin x, minus c cos x differentiation is minus sin x divided by 20 x cube. Okay, so let's simplify it. So can we say this is nothing but c minus 2b. If we take the things as constants, sin x minus bx cos x divided by 20 x cube. Again put the value of 0, x is equal to 0. So sin 0, this will make the whole term 0, and x is 0 here, it will make the term 0. 0 minus 0 again 0, and this is 0 already. So let's apply it L'Hospital one more time. Apply L'Hospital one more time. So limit x tends to 0. Can we say c minus 2b is constant? Nothing to worry. Sin x differentiation would be cos x minus b. What is the differentiation of x cos x? Can we say cos x minus x sin x, and this is divided by 60 x square. Okay, now let's put the values at 0. So can we say c minus 2b cos of 0 minus b into cos of 0 minus 0, and this is 0. Okay, and what is the limit? Already in the question it is given that it is having the finite limit. So can we say this is 1? So denominator cannot be 0, only numerator can be 0. So c minus 2b, what is the value of cos 0? This is 1. Can we say b into 1 minus 0 is equal to 1, and can we say this is nothing but c minus 2b minus b is equal to 1? Sorry, this can be 0 because 0 will be here and 1 will be here. So here can we say c is equal to 3. So we have the equation number 3rd and equation number 4. Okay, now coming from the equation number 3rd as well. Okay, we got this condition c is equals to 3b, but again it is making the numerator and denominator 0. So let's continue with this. Can we say let's put the values of c is equals to 3b. So let's put the value of here, or let me write it with different pen. Put c is equal to 3b. So can we say limit x tends to 0, 3b minus 2b into cos x minus b into, or b cos x plus bx sin x divided by 60 x square. Okay, so let me do it here. So limit x tends to 0, can we say b cos x minus b cos x plus bx sin x divided by 60 x square. Okay, so this is getting cancelled, this is getting cancelled. So can we say limit x tends to 0, bx sin x divided by 60. How do we write x square? X into x. So 1x will be cancelled, and this will be limit x tends to 0, can we say b into sine x by x? And let's take the b as constant outside, so limit x tends to 0 sine x by x, and what is this standard result? This is equal to 1, and 60 is also there, so b by 60. So can we say b by 60, and what is the final limit? This is nothing but equal to 1. So we have the fourth equation as well. So combining the all equation, what was the first equation? A plus b minus c is equal to 0, c is equals to 3b, and b is equals to 60. Okay, so when b is equals to 60, can we say c is nothing but 3 into 60? Can we say c is nothing but 180? Okay, and what is a? C minus b, so can we say 180 minus 60, and this is 120, so a is 120. So this is the solution for a, b and c. Now let's move on to the form number 2. Okay, what's form number 2? Form 2, that is indeterminate form, indeterminate form 2. Okay, so what is indeterminate form 2? This is nothing but 0 into infinity. So 0 into infinity, how do what can be this? In this we try to reduce to 0 by 0 or infinity by infinity form, and then we apply L'Hospital rule. Okay, then we apply L'Hospital rule. Okay, so how do we solve this one? Let us say, let limit x tends to a. If we are calculating for the function fx, let us say 0, and limit x tends to a, other limit is 0. So if we are calculating limit x tends to a, fx into gx, basically that means 0 into infinity. Okay, so how do we solve this thing? We just try to write the things in a different manner. How? What we'll do? We'll write like this. Can we say fx is 1 upon g of x? What is the benefit of this? Fx is 0 and 1 upon infinity is 0. It is taking the 0 by 0 form, or we can write it in different other ways, like limit x tends to a, can we say g of x and 1 upon fx. Again, gx is infinity and 1 upon 0 is infinity, so again it is taking the infinity. So you can see we have converted the 0 into infinity form either into 0 by 0 form or either infinity by infinity form, and then after we can apply the L'Hospital rule. Okay, just to make it more easier for you, let me describe it with numerical. Let us say this is a question, limit x tends to 0, and can we say tan x into log x. So if we'll put the values of x is equal to 0, can we say tan 0 is 0 and log 0 is infinity? So can we say this is nothing but taking the form of 0 into infinity? So how do we solve this one? So what can we do? This is the form of 0 into infinity. So how can we write like this? We can say log x by, can we say 1 upon tan x, can we say this is nothing but cot x, because 1 upon tan x would be cot x, or we can just to simplify it more, can we say 1 upon tan x, because this would give the same result, this would give the same result. So this is nothing but limit x tends to 0 log x divided by cot x. So once you put the values, this will take the form of infinity by infinity. Now this has taken the form of infinity by infinity, then what can we do? We can apply the L'Hospital rule. Okay, so what does the L'Hospital rule says? Just differentiate the numerator and denominator. So limit x tends to 0, what's the differentiation of log x? This is 1 upon x, and differentiation of cot x is minus cosec square x, and cosec square x is nothing but 1 upon sine square x, minus, take the things minus is common, so minus limit x tends to 0, can we say sine square x by x. Okay, so minus limit x tends to 0 sine x by x into x, this is 1, and when you multiply with 0 the answer is 0. So here you can see we have easily framed the 0 into infinity by infinity form, and accordingly we have calculated the limit. Okay, now let's move on to type 3. What is type 3? Type 3 is nothing but infinity minus infinity form. So how do we solve this infinity minus infinity form? Let us say, again we'll try to reduce it to 0 by 0 and apply L'Hospital. Okay, so let limit x tends to a, fx is equal to infinity, and limit x tends to a, g of x is infinity, then limit x tends to a, fx minus gx. How can we write like this? Can we say 1 upon gx minus 1 upon fx, and this is 1 upon gx into 1 upon fx. Okay, so here infinity by infinity form has been reduced to 0 by 0 form, because 1 upon infinity is 0, 1 upon infinity is 0, and 1 upon infinity is 0, 1 upon infinity is 0. Okay, so can we say this is coming the 0 by 0 form. Okay, now with the help of numerical, just get the more clarity, let's say there is a question is there, limit x tends to 0, can we say 1 minus sine x minus 1 upon x. If we put the values of x is equal to 0, so can we say 1 upon sine 0, 1 upon 0, this is coming infinity, this is coming infinity, so here you can see this is taking the form of infinity upon infinity. Okay, so how do we solve this one? Let us say limit x tends to 0, can we say x minus sine x divided by x sine x. Okay, now this has been the form of 0 by 0. If we put the values 0 minus 0 divided by 0, so now this has been converted to 0 by 0 form. So when there is 0 by 0 form, what we'll do? We'll apply the L'Hospital rule. Okay, so apply the L'Hospital rule, limit x tends to 0, what we'll do? We'll just differentiate the numerator and denominator. So differentiation of x is 1, sin x differentiation is cos x, and what's the differentiation of x sin x? This is x cos x plus sin x. Let's put the values at 0, so can we say 1 minus cos 0 divided by 0 plus sin 0, again it is 0 by 0 for. So what we'll do? We'll again differentiate this. So 0 cos x differentiation is minus sin x, so minus sin x, and this is x cos x differentiation is minus x sin x plus cos x, and differentiation of sin x is cos x. Now let's put the values, and here you will get sin 0 divided by 0 plus 1 plus 1, can we say 0 divided by 2? Answer is 0. Okay, now let's move on to the last form, that is indeterminate form. Indeterminate form type 4. So type 4 can be like 0 to infinity, or 1 to the power infinity, or infinity to the power 0. So under such circumstances, what we used to do? We used to take log and make it to 0 into infinity form, and then convert to 0 by 0 form, and then apply L'Hospital rule. Okay, again take log, make it to 0 into infinity, okay, and 0 by 0 form. Clear? Now let's get it over the more clarity with the help of numerical. Okay, let's say a numerical is there, limit x tends to pi by 2, and sine x to the power 10x. When we put the values sine pi by 2 and tan pi by 2, can we say sine 90 is 1 and tan pi by 2 is infinity? So this is the form of 1 to the power infinity. So what we'll do, we'll take this as log, consider this as y, limit x tends to pi by 2 sine x to the power 10x, take the log on both sides, take log. So can we say log y is equal to limit x tends to pi by 2, this is 10x into log of sine x. The benefit of this is like this. Now if we'll put the values of tan, can we say tan pi by 2 log of sine pi by 2. So this is 1, can we say this is 0, and 10 pi, this has been converted to 0 into infinity form. So how do we solve 0 into infinity form? We just take the reciprocal things and rewrite the things in a reciprocal manner. So can we rewrite the things like this, log of sine x divided by 1 upon 10x, this will be the same result. Okay, can we say log of x to the power pi by 2 10x can be written as log of 1 upon 10x can be written as cot x. Again, when we'll put the values, so log of sine of pi by 2 and cot of pi by 2, so this is now taking the form of 0 by 0, and once it is 0 by 0, what we'll do, we'll just differentiate it, numerator and denominator. So limit x tends to pi by 2. So what's the differentiation of log sine x? Log sine x is, first consider this as capital X, so log x a differentiation 1 upon x and further differentiate at x. So log x a differentiation 1 upon x का differentiation हो जाए 1 upon sin x, and sin x का further differentiation cos x. So log sin x would be cos x upon sin x, and cot x का differentiation minus cosec square x. Okay, so let's simplify the things. X tends to pi by 2 and this is y. Okay, so cos x by sin x, and cosec square x is nothing but minus sin square x, it will be in the denominator part. Okay, so can we say limit x tends to pi by 2 and minus sin x cos x. Okay, so again put the values as pi by 2, you will get the answer as 0. So y is equal to, this was log y. Okay, if you look at the result, this was log y, so log y is 0. So how do we solve this one? Y is equals to e to the power 0 and answer is 1. Okay, now let's take the one more last